Welcome, everybody. Thank you for joining us and taking the time today for our asbestos and other hazardous materials in the built environment seminar that we put on. Very pleased to see such strong participation. We had over 120 participants registered, and I can see over 50 right now on the call. We have folks from property management, construction, restoration, public sector, healthcare, education, insurance, and industrial organizations. So it just shows you how broad hazardous materials impacts everybody. I'd also like to extend a special welcome. We have some colleagues from WorkSafe BC on the line today as well. And we appreciate, of course, your presence and the important role you play in advancing worker health and safety across BC here. My name is Hussein Jaffer. I'm the director for the Hazardous Materials Group at Pynchon. For those who may not be familiar with us, Pynchon is a multidisciplinary consulting firm operating across Canada. We support clients through the full life cycle of their facilities and projects. Today's session is focused on hazardous building materials, but our work does span a wide range of complementary, well-established disciplines, including occupational and industrial hygiene, environmental due diligence and site assessments, building science and sustainability, indoor air quality and mold, remediation, abatement oversight, and construction support. This multidisciplinary approach allows us to look at hazardous materials not in isolation, but in a broader context of worker safety, regulatory compliance, building performance, and risk and asset management. So I do urge you to maybe have a look at our website to see some of the other things that we do that may support your day-to-day work and your projects that you have going on. Today's session is intended to be practical and current. It's focused on hazardous materials, particularly asbestos, lead, silica, mold, mercury, and PCBs, and how they continue to impact the built environment, and what owners, managers, employers, and constructors need to know to achieve and maintain compliance here in BC. I'm pleased to be joined by two of my colleagues who bring extensive hands-on experience. Larissa Braun-Neville, who's our project manager in our hazardous materials group. Larissa works closely with building owners and property managers on hazardous material inventories, risk assessments, ongoing compliance programs, and she has a strong focus on translating regulatory requirements with practical management strategies. Also have Darren Roper. He's our operations manager with our hazardous materials group. Darren has an in-depth experience supporting complex projects. That includes pre-construction, hazardous materials assessments, abatement oversight, and coordinating with contractors and stakeholders. His perspective does bridge the gap between technical requirements and real-world project execution. Together, the both of them will walk you through key hazardous materials commonly encountered in buildings, applicable and evolving regulatory requirements here in BC, the difference between management inventories and pre-construction assessments still seems to be lost on some folks today. And what effective compliance looks like in both day-to-day operations of your buildings, as well as while executing your capital projects. We encourage you to submit questions through the session through the chat function here, and we'll address as many as we can towards the end of the presentation. With that, I'll turn things over to both Larissa and Darren. Thank you.
Hello all. Thank you for joining us today. We're going to, as Hussein mentioned, our seminar, the intention is for this to be a broad overview for those attending, where we discuss the various hazardous materials that can be found in the built environment. We'll touch on key applicable regulations, as well as reintroducing the new asbestos worker regulations that were in effect as of January 1st, 2024. We'll also touch on how to achieve and maintain compliance so that you're ensuring that you are following all of the regulations and the various roles and responsibilities, whether it falls to the owners, prime contractors, constructors, etc. So we'll jump into the hazardous materials. As Hussein said, our primary focus will be asbestos, lead paint, lead products, silica, mercury, PCBs, and mold. However, this is not an extensive list of the hazardous materials that you can encounter in your buildings. There are other materials such as radioactive materials, guano or rodent wastes, ODS, which is the ozone depleting substances in chillers and air conditioning systems, etc. So the main focus is typically asbestos. So first we'll touch on what is asbestos. It is not a man-made product. It is naturally occurring. It's found throughout our environment. It's a fibrous silicate. And there were asbestos mines located throughout the world on all 6 continents, of course, not in Antarctica. And one of the larger mines in Canada was in Quebec. And there are 2 different families of asbestos. There are the amphiboles, which are considered to be more hazardous in that their fibers are shorter and more needle-like. And then the most common type of asbestos that we encounter in the built environment these days is chrysotile, and that is in a family of its own. And it is a more fibrous and flexible serpentine type of asbestos. Now we are much more aware of the human health effects and the consequences of exposure to asbestos. But previously, it was considered a miracle mineral. It wasn't recognized for its negative health impacts on humans, but it was recognized for all of the benefits that it provided to the built environment. And that's why it was used so frequently. So it used to be inexpensive to mine and process. It is fire and heat resistant. And it's also non-conductive and a great electrical insulator. When asbestos fibers were mixed into other products, it increased their durability and their strength. It is inert, so it's non-chemically reactive. It also resists biological growth, so mold and mildew don't grow on asbestos cement pipes, for example. And particularly chrysotile, it's a very flexible mineral, so it can be woven into textiles or paper and incorporated into a lot of different products. And so that's why it was extensively used before we really understood the significant health consequences. So we'll look at the 3 predominant health consequences from exposure to asbestos. The first is asbestosis. Unfortunately, it's an irreversible illness. It is not a cancer. It's instead a form of fibrosis. So essentially your body's defense system, when there are foreign bodies or particulate that come into your lungs, your body fights against that. And that repeated fighting against those foreign particulates causes a lot of scar tissuing, and your lungs become less flexible and harden. And so that's what causes asbestosis. And there are certain latency periods. So from the initial exposure to the material, so to the asbestos, and then when the person would demonstrate symptoms, asbestosis has the shortest latency period, so 10 to 20 years. Whereas mesothelioma, which is a form of cancer that affects the lining or the pleura of your abdomen or chest cavities, has a much longer latency period, so 30 to 45 years. So when we think of that, how does that translate? If you consider a drywaller working in the 1970s, working in a house, installing drywall, sanding down the mud, not realizing that there are dangers from asbestos exposure, and they're breathing in all of those fibers through their work. that drywaller in the 1970s could show signs of asbestosis or negative impacts as early as the late 80s or the 1990s, whereas that same drywaller in the 1970s, if they instead contract mesothelioma, may not show the effects of that early exposure up until the 2000s. And the other significant illness is lung cancer itself. And this can be caused by lower levels of asbestos exposure than asbestosis. There isn't a defined or confirmed latency period, but it is still, somewhere from 10 to 40 years from that exposure. And unfortunately, smoking has a synergistic effect where those people that are smokers, their lungs' ability to utilize your natural defenses is already compromised. And so those people that have as exposure to asbestos and are smokers, their risk of cancer is up to 25% greater. So why are we still talking about this right now? Unfortunately, and these are our new stats that you can see here, as worker-related deaths due to asbestos is still the highest cause of work-related disease and death and illness. So it's still a significant issue, and part of that is due to the latency period that we just looked at, but it is still a good reason for prime focus to continue to try to reduce worker exposure and work towards healthy workplaces. So we're going to look at the uses of asbestos in buildings. This isn't going to be an extensive list. There are hundreds and hundreds of products that have had asbestos added to them historically. We're going to focus on some of the more common asbestos-containing materials. And here in British, throughout the industry, they typically categorize it into two different groups. There are friable asbestos materials and non-friable. So we'll look at both of those. And in British Columbia, the regulatory criteria or the definition of an asbestos material is a manufactured article or product other than vermiculite that has at least 0.5% asbestos content. And for vermiculite, that's a special case. If there's any amount of asbestos fibers identified in vermiculite, that product is considered to be an asbestos-containing product. Here you can see there's also an image that just has a rough outline of all of the different areas in a building or a home where you could find asbestos. And we'll work our way through some of the more common applications. So a friable material, this is considered to be a more dangerous state for the asbestos to be in because it has a greater ease of fiber release. So the definition is that if you can manipulate the material by hand and you can powder or crumble the material and therefore cause fibers to be released, then it is considered a friable material and it has an ease of fiber release. So friable materials in British Columbia are specifically regulated, and they must be controlled by either removing them entirely, encapsulating them, or enclosing them. And this is to control fiber release. The other category of material for products is non-friable. So this is any product that would maintain its integrity if you manipulate it by hand, if you rub your hand across it, it doesn't immediately release fibers. It needs to be exposed to a greater aggressive force. So again, if you're using power tools or something like that. So those non-friable materials are considered to be slightly less hazardous because they have a lower likelihood of fiber release. That doesn't, of course, mean that they are not dangerous or hazardous. They are not as hazardous as the friable materials. And a lot of people don't realize this, but Canada federally did not ban the use, sale, manufacture, or import of asbestos until December 30th, 2018. So effectively, if you could think of 2019 was sort of the ban date. However, most friable materials, the use of the friable materials, because again, they were identified as more dangerous and they were legislated against earlier on, they did start to taper out in the late 70s and early 80s. So some common applications of friable materials that we would see in the built environment would include ceiling tiles. So these are acoustic ceiling tiles. They can be lay-in ceiling tiles, glued-on ceiling tiles, splined or mechanically fastened. Spray applied fireproofing. So this is a product that can delaminate easily, and there can be a lot of debris associated with it. There are also mechanical insulations that are friable, so they can be found on boilers, vessels, pipes, ductwork, and they're considered a friable material. Paper-backed vinyl sheet flooring is also a friable material. Textured finishes, so these are what we would think of as a popcorn ceiling, for example. And then the last one here on the bottom right, you are looking at vermiculite. So vermiculite is a loose insulation product. It can be found in residential applications, in attic spaces. It's oftentimes found in block walls, used as an insulation and a sound dampener, but there's lots of different areas where we've identified vermiculite to be present. Next, we'll look at the most common applications of non-friable asbestos materials that we find in the built environment. So the most common two, I would say nowadays, is drywall joint compound. So the image on the left-hand side here, this is a wall with drywall joint compound, and you can see that this particular tradesperson was very thorough. They mudded the seams in very wide bands, and they've applied the joint compound to every screw, nail, and anchor. So this image very effectively illustrates why, when we find asbestos-containing drywall in a building, you have to assume 100% application of the joint compound on the drywall. You can't just say, oh, okay, we know drywall is built in, 4x8 sheets. If I just move 2 feet up the wall and I cut a hole there, I'm fine. In this case, no, that's not the case, particularly when it's painted. We can't tell where the joint application is and is not, so we assume 100% application. The next photo here, we're looking at vinyl flooring. So it can be 9x9 floor tiles, 12x12 floor tiles, and also in the cove base itself is where asbestos can be mixed into the product. Other non-friable common materials that we will see is duct mastics, window putties and mastics, floor mastics, and cement soil pipes. And I've circled there for everyone. You can see the date stamp, so 130107. I hope you understand that this means that, yes, there are asbestos-containing materials in the built environment, even up into the 2000s. There used to be sort of this cutoff date of 1990 that was kind of floating around as an assumption that one wouldn't find asbestos-containing materials past that point, and that is not, in fact, the case. As mentioned earlier, the federal ban date took effect essentially as 2019. So it is possible to find asbestos-containing materials in British Columbia up until that date. So next we'll look at the 3 primary pieces of legislation here in British Columbia that speak to hazardous materials regulations, not just asbestos, but also the other hazmats we'll look at. So the first is the Occupational Health and Safety Regulation. So this is, what WorkSafe BC is enforcing. And there are 3 main parts that speak to hazardous materials. Part 5, which addresses chemical and biological substances. Part 6, which is substance specific. So this speaks to asbestos, for example, and lead and silica. And then part 20, which addresses construction, excavation, and demolition. The second piece of legislation is the hazardous waste regulation. So this is from the Ministry of Environment. And the third is the transportation of dangerous goods. And this is a federal regulation. And this speaks to how hazardous wastes need to be transported, handled, manifested, and disposed of. So one of the things that Hussein mentioned is the the difference between an asbestos inventory or a management assessment and pre-construction. So we'll touch on that a little bit more in greater detail. So there are regulatory requirements for an asbestos inventory or a management assessment. And this is required so that asbestos-containing materials are both identified and managed in every workplace. And the employer must ensure that a qualified person, so that would be a trained and certified consultant, develops an asbestos inventory for that workplace. And there is a requirement that the inventory be kept current. And so this is why one would conduct reassessments. So you're making sure that you're documenting any changes to the inventory. So it could be the quantities of materials could have changed. Perhaps there was a renovation and some materials were abated and removed. Or unfortunately, maybe the condition has changed and the materials have deteriorated, and then it would trigger remedial actions. So there are certain components that an inventory must include. It has to identify where the samples of the suspect asbestos materials were collected from, including a description of the material, those sample results, and any extrapolations that have been made. So if we sampled a floor in one room, is that result also extrapolated to all of the other rooms that flooring is present in? The methodology that was followed, and were there any limitations, or are there presumed and inaccessible materials that one still needs to be aware of, but we don't have a definitive answer as to whether or not they are asbestos materials. And then a requirement for drawings or floor plans that show where the samples were collected and the conclusions. And why do we complete specifically the baseline or the asbestos inventory? This is to ensure public health and safety, the well-being of all of the workers, including the general public and contractors. And it's only required for asbestos. So there is not currently a regulatory requirement for an inventory for lead paint, for example. However, it is something that you can add onto your management assessment. You can include other hazmats, so you have a baseline inventory for your building. And it is important to understand that management level assessments, particularly if they're only for asbestos, are not intended for project-specific work, so renovations or building demolitions, etc. So why, in fact, are the inventories and the reassessments conducted? One of the key pieces is, are there any remedial actions required? What can we do to continue to prevent worker exposure? So here you see in this image, there was an assessment that was conducted, and all of this pipe insulation was identified to be in poor condition. And then on the right-hand side, it's been remediated, it's been tidied and cleaned up, and now that worker likelihood of worker exposure has been reduced or mitigated altogether. So the second piece of the assessment, and what's the difference, is the requirement for a pre-construction assessment. So this is required for all hazardous materials, and it must be conducted before all construction activities. So sometimes people will say, you know, what constitutes a construction activity? So here we've noted it can include significant repairs and maintenance. So for example, if you're repairing in an industrial setting, you're repairing a very large boiler and you need to take apart the components and maybe switch out the gaskets, you're doing maintenance. Taking apart that very large boiler could disturb the insulations, it could disturb paints on the boiler, and it could disturb the gaskets themselves. So even though you're considering that a repair or a piece of maintenance, you still could disturb lead paint and asbestos. So it is important to be aware that anything that has a likelihood to disturb a hazardous material, you should have an assessment conducted. And it needs to include all hazardous materials, so it's not limited just to asbestos, but it should include other hazmats. And you can use your baseline assessment or your previous historical information, and you can augment that into a pre-construction assessment. So you don't have to duplicate your efforts. If you already have information about asbestos in your project area, you can rely on that information, but you need to make sure that you're supplementing that information so you're meeting all of the regulatory criteria. And also under Part 20 is the requirement to file a notice of project at least 48 hours in advance of any work that would disturb hazardous material. There is, of course, an exception if there is emergency work that needs to be done. So if there is a flood or a spill, one, of course, would respond to that spill, mitigate the likelihood of exposure, and then file the notice of project at the earliest possible time. Also included in Part 6 of the regulation is the requirement to identify the asbestos-containing materials in the workplace. So this would follow your asbestos inventory or your assessment. You would then take that information and incorporate that into a means of identifying those asbestos-containing materials for the building occupants, workers. So there are many ways to do this, one of which would be labels or signs directly on the material itself. So for example, if you have a very large boiler in a mechanical room and the boiler itself is insulated with asbestos, then the insulation on the boiler itself would have the label. Alternatively, there are labels that are affixed to a door jamb. So on the far right-hand side here, you can see an example of a label that is a QR code. If you'd like to, you can scan it with your cell phone right now, and the information will pop up. This label is dynamic and live, and it inventories the hazardous materials identified in that room. The benefit of having this particular type of labeling system is, as I mentioned, it's dynamic. So if there's any remediation that's conducted in this room, for example, and then the inventory system is updated, the next time you go back into that room and scan the label, it will have that updated information. Other means of identifying asbestos-containing materials could be marked up floor plans. So you can see these here are color-coded. They're identifying which types of asbestos materials are in which locations. I mentioned the newest change to the regulation for in effective January 1st, 2024. And BC was actually a leader in Canada to require licensing and worker certification for all workers that are managing and impacting or disturbing asbestos-containing materials. So this is applicable not only to asbestos abatement contractors, but also consultants like ourselves. And there's a requirement that these employers are to be licensed by WorkSafe. And then the asbestos abatement companies that are hiring their own workers have to ensure that each of their workers are certified. There is an online exam that everyone has to complete to achieve their certification. And this then means that the abatement contractors have to make sure they're hiring only trained and certified workers. And then the owners or yourselves must ensure that you're hiring only licensed abatement contractors to conduct asbestos work. This link here at the bottom that I'm just demonstrating for everyone, the WorkSafe BC Asbestos License Registry, online, you can very easily look up by the registered company name, whether or not they've been issued a license by WorkSafe BC here in British Columbia. So who does the license apply to? So it applies to all asbestos abatement contractors, restoration contractors, any renovation contractors who are, in addition to conducting renovation, also providing abatement services, and the same for demolition contractors. So if a demolition contractor, of course, doesn't do abatement themselves, they sub it out to someone else, this doesn't apply to them. But if they are conducting abatement under that same umbrella, then they need to have the same licensing and certification. As well, it applies for waste transport and disposal contractors. As I mentioned, asbestos surveyors, so Pynchon and other consultants. And any trades or other persons who, in addition to their primary services, are also offering any abatement services. So that's the newest regulation, the newest change or update, effective 2024. Next, we'll look at lead paints and coatings as well as lead products. I was surprised to know, you can see here from the graph, the primary use of lead in all products in the built environment is in fact lead batteries. But we'll look first at the characteristics of lead and the sources of lead. So similarly to asbestos, lead is a naturally occurring heavy metal, and it is abundant in our environment. And it was used for all sorts of different reasons. It has a low melting point, it's water resistant, and it protects against corrosion, so resistant to rusting, things like that. It also makes pigments brighter and more vibrant, so that's why it was previously used in paint. And the sources of lead, so the reasons why we would encounter them in our built environment. So as I mentioned, lead acid batteries, that's the largest use. Paints and coatings, also plumbing. So of course, we've all heard about lead pipes for drinking water. That's been a concern, and people are trying to change that over to different kinds of piping, so that's no longer an issue. There's also lead sheeting or shielding, so X-ray spaces, walls that are lined with lead sheeting for protective purposes. It's also found in ammunition and fishing weights. So we've just recently been supporting with some lead wipe assessments of gun ranges. So another place that we would find lead products. And previously lead was also found in cosmetics. Of course, we now use unleaded gas, but previously there was lead in petrol, and also in electrical cables, as well as in other products such as glass and ceramics. Unfortunately, lead has some very significant health consequences through lead exposure, and you can be exposed to lead through all three different ways, I should say: ingestion, inhalation, and also skin contact. Children have much higher absorption rates, and so unfortunately, there's a lot more deleterious effects to children being exposed to elevated levels of lead. And when we do breathe in the lead dust, up to 90% of that can be taken up by our bloodstream. So the significant impacts include neurological damage. So there can be seizures, developmental disorders, cognitive impairments. So behavioral changes, depression, anger, all sorts of negative impacts there. Cardiovascular damage and disease, kidney damage, also reduces fertility. It can cause miscarriages, and as well as birth defects, as well as digestive system issues. Fortunately, when one is exposed to lead, you can go through a number of treatments, and they can help reduce that lead burden that's in your body, unlike exposure to asbestos. There isn't really any after the fact treatment that can take the asbestos fibers back out of your lungs, whereas there are treatments available for persons that have been exposed to lead, and they can help reduce your lead burden in your body. Lead was not regulated in Canada until 1976, and even then, the amount of lead that was allowed in products was still considered quite high to today's standards. So it was regulated at 0.5% by weight. That translates to 5,000 parts per million, or the rough equivalent of 5,000 milligrams per kilogram. And then in 2005, the regulations reduced that even further to 600 parts per million. And now the regulation federally reduces that to 90 parts per million. There is still some exemptions, so there are no restrictions for anti-corrosive or anti-weathering paints. So those are the exemptions. And WorkSafe, similarly to Saskatchewan, does not have a numerical definition of what would be considered a non-leaded paint versus a leaded paint. All right, and now we'll look at some of the other hazardous materials mentioned. You can see this worker here is definitely exposed to a number of quite a significant amount of dust there from the work that they're conducting. So they are using a jackhammer on silica. So silica is another hazardous material that's in our built environment. It is one of the most common minerals throughout the Earth's crust, and it's also a basic component of a lot of materials that we use in the building. So concrete, cements, mortars, quarry stone, masonry, brick, refractory, stucco, plaster, terrazzo flooring. So there is silica in almost every built environment. We do not test, so we don't take bulk samples for silica and test for it. It is a known component of all of these materials. And the hazard is from respirable crystalline silica, or we've shortened it here as RCS, or rock, as well as rock dust. And the various exposure risks come from any time that you are disturbing the silica product and you are creating any dust or debris. So that can be through chipping, grinding, hammering, cutting through stone, conducting abrasive or hydroblasting, or of course, building demolition itself. And when you breathe in respirable crystalline silica, there are several different lung diseases. So silicosis is similar to asbestosis. They have the same result. It's a fibroid illness of the lungs, a hardening of your lungs, reduced capacity. One is obviously caused by asbestos and the other by silica exposure. There's also bronchitis, and more workers in British Columbia are exposed to silica dust than asbestos or lead, again, because of its prevalence throughout the built environment. Next, we'll look at mold. So there are, of course, background mold throughout our environment. There are more mold spores in the air we breathe every day. And mold is a good thing. It helps us, it breaks down organic matter, so decomposition of plants and animals. However, in buildings, mold growth can cause structural damage, odors, and other health risks. And you can't kill mold spores by disinfectants or UVs alone, or even heat. It doesn't make the mold spores safe. They still can contain allergens or other mycotoxins, and they have to be removed at the source and then encapsulated. So some of the health risks or health effects from exposure to bad molds, people can have just simply allergic reactions. There's also respiratory symptoms. It can definitely exacerbate asthma or already existing lung conditions. One can have sinus infections and other systemic health impacts. So there's four main causes of mold growth in buildings. So the first would be a building envelope failure. So if the envelope fails and water gets in from the outside, there could also just simply have been poor construction practices. Or flooding. So of course, if there's interior floods, pipes burst, sprinkler release, or condensation. So if the air exchange from the inside and the outside of the building is very extreme, then mold can form. And it takes only 2 days for mold to grow on some building materials, such as the cellulose of drywall paper is a favorite food for mold. And it can grow very, very quickly in prime conditions in certain environments. Next, we'll look at mercury. So mercury is, again, also a natural material. It has 3 different forms, so elemental, inorganic, and organic. Very toxic to humans and the environment, causes both neurological damage as well as kidney damage. Where would we find mercury in the built environment today is predominantly in fluorescent light tubes, or if you still have older heating systems, then it could be in the ampules, in thermostats or boiler control switches. It's very important that when we are disposing of mercury or handling it, that we're not releasing it into the environment. So being conscientious to not break those fluorescent light tubes. Luckily, most recyclers here in British Columbia will accept both mercury ampules or mercury waste as well as the fluorescent light tubes. They handle them safely and will dispose of those. And I'm not sure if many people on the call are aware, but federally, mercury has now become regulated, and there is similar to the asbestos regulation, there are new prohibitions to the import, manufacturing, and sale of mercury products. There are some exemptions, but the first prohibition was in effect already as of January the 1st. So for those of you that are considering relamping your buildings, you will no longer be allowed to relamp with fluorescent light tubes. Next, we'll look at PCBs, polychlorinated biphenyls. So these, unlike the other hazardous materials we've looked at, are man-made. They are synthetic, and they were created of chlorine, carbon, and oxygen. They have a bitter odor, and they were first synthesized in the late 19th century and used extensively throughout the world, but the production declined in the 1970s when we understood the negative impacts of the use of PCBs. So they were banned in Canada in 1980. Canada didn't produce any PCBs at all. We imported a significant amount of PCBs, so up to 40,000 tons is estimated that were imported into Canada, largely from the United States. They were the largest producer and consumer of PCB products. So PCBs are found in transformers, so pole top transformers, transformers inside buildings, capacitors, voltage regulators, so light ballasts, hydraulic fluid, so in an elevator, so an elevator that typically services a building that's lower than 4 stories could have a hydraulic elevator with fluids. Also used as electric cable insulators, oils, and lubricants, and can be found in paints and caulking adhesives and tapes. So there's lots of different applications or uses of PCBs. They've been very stringently regulated, and a lot of them have already been taken out of the environment. But in your built environment, the predominant place that you may still find them is going to be in light ballasts. Health impacts and environmental impacts of PCBs. So PCBs are very persistent. They are very hard to break down, and they can travel long distances in the atmosphere and the waterways. They bioaccumulate. So as they make their way up the food chain, they magnify and they increase. They stay in our fatty tissues. And similarly with the other hazmats that we've looked at, they can interfere with your neurological development, your hormone or your endocrine system, reproductive issues, also increases cancer risks and impacts your kidney and cardiovascular system. So I did mention they were, fairly stringently regulated, and all light ballasts, pole top transformers, and other small equipment were meant to have been removed from the built environment, taken out of your inventory, and sent for destruction as of last year, so December 31st, 2025. Within the last month or so, the federal government has indicated that they've extended this cutoff date to allow persons to finish their audit of their built environment, their light inventory, essentially. So now you have until December the 31st, 2026. They've extended this deadline. So now that we've reviewed the most common hazardous materials that are present in the built environment and some of the regulations that govern them. This, of course, as I mentioned, isn't an exhaustive list. We'll review how do you maintain compliance. So earlier I mentioned the three primary pieces of regulation. Here we're looking just at the first, the occupational health and safety regulation, and those three parts that we looked at. So part 5 talks about chemical and biological substances. This is where we find occupational exposure limits, for example. So the exposure limit for asbestos is 0.1 fibers per cc, so that's cubic centimeters. This it can be equivalent to 100 fibers per liter, but that doesn't, of course, mean that you're breathing in 100 fibers in a single liter. This is an exposure limit over a workday average or a time-weighted average, so it's estimated or approximated at 8 hours. Similarly, this piece of the regulation also introduces exposure limits for lead. This is only for airborne lead. One also has to consider that you can eat or ingest lead. So this exposure limit is only for airborne lead. It doesn't account for the lead that your body could ingest. There's also exposure limits for, we mentioned respirable crystalline silica. So if an employee or worker is if there's a potential that they may be or they will be exposed to 50% of that occupational exposure limit of any airborne contaminant, then the employer must develop an exposure control plan. And the exposure control plan has to identify how to safely protect that worker and try to reduce that exposure. It outlines roles and responsibilities, decontamination, personal hygiene, exposure controls, etc. The other piece that Part 5 speaks to are designated substances. So these can be carcinogens. They can be substances that interrupt or reproductive issues. They can be sensitigens. So there are Part 5 speaks to designated substances, which includes, of course, asbestos as a known human carcinogen. Part 6, that's largely what we touched on when we were looking at the requirement for an asbestos assessment or inventory. This also indicates how you identify asbestos, the type of risk assessments you must conduct, the requirements for an exposure control plan. And there's also, it outlines how to conduct asbestos abatements, what type of PPE is required, all sorts of different controls. Part 6 also addresses similarly the same thing for lead and lead processes. So anything that would disturb lead paint or products, the requirements for a lead exposure control plan, and the types of steps one follows for lead abatement. Similarly for silica as well, and the requirements for a silica exposure control plan. And I've just demonstrated down here a really helpful link that is available when people are planning silica work. There is a silica control tool that can help one develop the exposure controls that need to be in place. And then again, the third significant part of this regulation is Part 20 that addresses the need for a pre-construction hazardous building materials assessment. Anytime you are doing renovations, repairs, demolition, or excavation. And then again, the requirement to file that notice of project. It used to be referred to as NOPA. We now refer to it as NOPH, so Notice of Project for Hazardous Materials. And those hazardous materials include asbestos, lead, or other heavy metals. So that could be a significant disturbance of mercury, and any toxic, flammable, or explosive materials would also be included there. So how can we help? So these regulations apply to owners, so people that own the built environment, as well as employers that are working in the built environment. And it's important that you're making sure that all the work that you're conducting is meeting these regulatory requirements. So there's day-to-day requirements for management of hazardous materials. So we've touched on this, the requirement for an asbestos inventory or assessment. And then to keep it current, you conduct the reassessments. This is how you're managing it. You can then also prepare an exposure control plan or an asbestos management plan. They work with you hand in hand to identify your procedures and policies. Once you've conducted your asbestos assessment and you've identified that you have asbestos in your building, how are you then identifying the asbestos to the other occupants and workers in that building? And you're doing that through labeling or other means. Once you've conducted an assessment, are those materials in good condition? Or do you in fact need to enact remedial actions? Do you need to correct a deficiency or repair a material? And then if you've conducted that remediation or abatement, there is a requirement for a qualified person to prepare a closeout letter documenting that the materials were handled safely and are now enclosed or encapsulated. And then further, there are requirements for training. So we can provide training classes for those that are managing asbestos. People that are administering your exposure control plan or your AMP would fall under those that definitely would require training. And also, how do we help for pre-construction? So in this case, both the owner and the representative and the employee, but also the prime contractor, are responsible to ensure that all of the work that is conducted in those spaces meets the requirements of the regulation. So here, again, you need that pre-construction hazardous material assessment for any and every renovation. And then following that pre-construction assessment, how do you translate that into your construction work? So then you would develop, or a consultant would develop for you abatement specifications, and we can provide tender support. Once that project has been awarded, then you want to again make sure that your abatement contractor are following the regulations and the work that they're proposing matches exactly the work that you need done. So we can review the contractor quotes, we can review their work plans, their documents, and also help validate any change orders as the project progresses. And there are potentially concealed materials found, quantities have changed. We can review that and ensure that the costs are appropriate and in line with the work planned. Pigeon can also help by directly coordinating and managing abatement on your behalf, or we can simply provide abatement oversight. So the requirement for site reviews or inspections, air monitoring, and contractor reviews. And then again, similarly to when remediation is completed, we can provide abatement completion reporting. This also meets the requirements from a qualified person to confirm that the abatement was conducted. But for many jurisdictions, this also helps support your building permit applications. Lots of different jurisdictions require completion reporting before they will issue those building permits as well.